Hey everyone! Today I want to show you a 3D printed airplane by Titan Dynamics, the Tornado V2. This is their first second-generation model, and it's packed with some cool upgrades. Let's take a look at what's different this time around. Also, I recorded the assembly process, which you'll find at the end of the video, along with some of the pitfalls I ran into while building it. Hopefully, those can help you out if you're planning to build one too. The Tornado V2 has a wingspan of 1 meter, almost the same as the first generation, just 3 centimeters shorter, with a nearly identical wing area of 1,955 square centimeters. The wing design now allows for tool-free detachment, which means no more screws. What I'm most excited about is the new quick-release connector system at the joint. 3 3-pin signal connectors for servos and ESCs. You'll need to grab some servo extension cables. I'm not entirely sure why they designed it with 3 connector slots, but maybe it's just right if you're adding a VTOL servo. There's also a small hole in the connector housing. It could be used to route VTX or GPS wires, although doing that would defeat the quick-release feature. Unlike Titan's mid-sized models like the Super Talon, which use 1-meter-long carbon tubes running through the entire fuselage, the Tornado V2 uses separate carbon tubes that plug into another tube inside the fuselage. This helps cut down on costs, especially since long carbon tubes are super expensive to ship to the US. The fuselage is spacious, with a wide-open canopy. I can fit my entire hand inside, which makes wiring way easier. The Tornado V2 feels good in the hand and is well balanced for a one-handed launch. I printed several 4S 2P battery compartments for both 18,650 and 21,700 cells in different configurations to test the space. These dimensions are just for the battery shapes, so no spacers or padding included. Titan also includes a small printed part to help position the battery. It's useful if you're sticking with just one type. The hatch latch is now a screwless 3D printed part, and it works really well, definitely more secure than the magnetic latches on the Micro Talon and Hammerhead. But if the latch breaks in a crash, you'll need to reprint the whole hatch. Magnetic latches, at least, can be reused. I had to use a lot of heat set nuts for this build. Honestly, I wouldn't build a second one. The Micro Talon and Hammerhead are much simpler. For the holes, I recommend only using XY compensation for the wing carbon tubes. Otherwise, the heat set nuts might be too loose. I had a few M3 nuts just slip right in. In some spots, I just glued parts to save time. Let's talk about the optional nose, fuselage, and wing configurations. For the nose, aside from the standard 19mm analog FPV camera mount, there are options for DJI, with 2 holes, an airspeed sensor, GoPro, servo mount, and even a walk snail version with antenna holes and a VTX bracket. The wings also come with pre-cut holes for accessories. I printed mine without them. When I built the V2L Hornet, I tried mounting the VTX and receiver in the wings. That turned into a wiring nightmare. Had to solder longer wires and it got messy. Now I just keep everything in the fuselage. The rear fuselage also includes a pre-cut hole for the VTX antenna. Routing electronics through the wings risks damage and crashes. There are 2 TPU landing skid options. I went with the minimal 3-point version. The vertical stabilizer has multiple options, including camera mounts and internal wire routing. I've always wanted this kind of tail camera angle. A few quick assembly tips. Don't install the tail first. It makes it harder to route camera or servo wires later. Use the vertical stabilizer with screw holes. Gluing it limits future changes. For the quick release, attach wires before locking the connector in place. I used hot glue, but regular glue might be stronger. Pre-wire everything before soldering to the flight controller. It'll save you a lot of rework. Camera wires may need extensions. Mine from the SpeedyBee F405 wing weren't long enough. The motor mount had a bit of wobble, so I reinforced it with hot glue. Make sure the wing carbon tubes fit snugly into the fuselage tubes. Even slight mismatches in diameter will require sanding. Otherwise, your quick release becomes a slow release. If you're really skilled, the quick release system can be precise and fun to use for field disassembly. But honestly, I probably won't do it again. Screws are just faster, and if you crash, you're reprinting parts anyway. Also, the Tornado isn't that big. It fits nicely in a car trunk, so you don't really need to detach the wings for transport. One thing I love about Titan Dynamics designs: their control surfaces use carbon tube hinges. They're smoother than printed TPU or tape hinges, but do take more effort with carbon cutting. Also, their designs are easy to slice. You can just set global infill to 3%. No need to fine-tune every part like with some other planes. I'm not saying those other designs are bad. They can be super lightweight with pre-built infill settings and 0% slicer infill. But they also tend to be fragile. Another reason I like Titan's planes: most of their wings are detachable. That's a must for me. 3D printed planes are fragile enough. I don't want to replace an entire fuselage or wing just because of some minor damage that can't be repaired. I've printed Titan planes in PTG and ABS. Their slicer-friendly infill helps reduce wing warping, unlike some other designs that rely on single-wall zero infill prints. Those tend to warp unless printed thick. I had to use 0.6mm walls, or printed in PLA or lightweight PLA. The manual lists a max hand launch weight of 2.2 kilograms. Mine comes in at about 1,600 grams with the battery, and around 1,100 grams without. I'm using an easy ABS filament that prints well with an enclosure. It has great layer adhesion and toughness. Since this isn't a vase mode design, I could print full plates overnight without needing to swap them out. On the other hand, some vase mode models with lightweight PLA can be ultralight and super fun to fly. I haven't done a maiden flight yet because I still need to balance the CG, which requires a 4S2P 21700 pack. And I don't have one yet. I don't want to use a bunch of rocks just to hit the right weight. I'll take it out for a maiden flight once I get the batteries and build the pack. That's it for this video. Up next is the assembly build. If you enjoyed this, don't forget to like, share, and subscribe.